In section 13.2, we're talking about finding probability and something called permutations, which we'll get to in a second. So we're going to start with an example. Let's say you go to a sandwich shop. We have 5 kinds of bread, 4 kinds of meat, 3 kinds of cheese, and you get to build your sandwich and choose what you want. How many different ways are there for you to arrange your sandwich if you pick one of each, a bread, a meat, and a cheese? So let's break this down. Let's say we start with bread 1. It's wheat bread or white bread, whatever you want. So we start with bread 1, and we pick one of the 4 meats. So we've got meat 1, meat 2, meat 3, meat 4. Okay, so already there's 4 options. Then, with each type of meats, let's say I choose bread 1 and meat 1, then I have 3 kinds of cheese. Cheese 1, cheese 2, cheese 3. For this, I have 3 kinds of cheese. For this choice, I have 3 kinds of cheese. And for this choice, I have 3 kinds of cheese. Okay, so just for this one bread choice, I have all of these options. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 combinations with just this one bread, because I could pick any of these 4 meats and then any of these 3 cheeses. So that's 12 combinations for just this one bread. But I have 5 kinds of bread, so I would have to do that 5 more times, and I would get 12 more options for each one. So 12 times 5, without having to write all of that out, would be 60 different options for a sandwich. So this is something called the multiplication counting principle. If you're trying to put something in order and you have different types of things, to figure out how many combinations there are, you take each number and multiply it together. So I have 5 kinds of bread, 4 kinds of meat, 3 kinds of cheese. How many different combinations? Multiply them all together, 60. So another example. How many ways can we arrange the letters A, B, and C? Well, I could just call it ABC. I could keep A first and I could switch C and B. That's the only ways I can keep A first. Then I would have to make B first, choose A and C. Then I could keep B first and go C, A. Those are the only options for B first. So then I could go C first, A, B, C first, switch A and B. These are the only combinations. So there's 6 ways I can arrange those 3 letters. What if I had A, B, C, D? So A, B, C, D. I could keep A and B, switch C and D. Then I could make C next, have B, D. I could make C next and switch B and D. Then I could make D second, have B and C. Could have D second and switch B and C. I could keep B first, go A, C, D. Switch those 2. I would have to keep going for a while to figure this out. So this example didn't seem that complicated, but this one, just adding one more letter, got a lot more complicated a lot quicker. So this one wasn't that bad once we thought about it, the one with the sandwiches. So why are these 2 examples different? I'm just arranging things for both. It said arrange the different combinations of the sandwich and arrange the different letters. So why are they different? Well, the first example had 3 types of things. Okay, so we were choosing from different types of things. The second example, we were choosing from one type of thing, and we were putting it in order. So when we do that, example 2, when we put one type of thing in order, this is called a permutation, and these can get a little bit complicated. So permutation is when we put one type of thing in a certain order. All right, so we're going to have a formula for this. We need to define something first. We need to define what's called a factorial. So when you see a number or a variable with an exclamation point next to it, that stands for factorial. So what a factorial is I take that number and then I multiply it by the next number smaller than it, so n minus 1. So if n is 6, the next number would be 6 minus 1, which is 5. The next number would be n minus 2, which is 4. N minus 3, so on and so forth, until I get to 1. So for example, like I use the example of 6, I would take 6 times 5 times 4 times 3 times 2 times 1. Multiply all that together, that would be 6 factorial. So our permutation formula, which is on the next page, deals with factorial. So this is our permutation formula. NPR equals n factorial over n minus r factorial. And this is probably your reaction to that. So let's break it down. N is how many objects we have. So this part is just saying that we're taking a permutation, and we'll fill that in a second. So the N is how many objects we have to choose from. The R is how many we're actually choosing. So if we have the letters A, B, C, D, E, F, G, we have 7 letters to choose from, and we want to pick, we have to decide how many we want to pick. So let's say we're going to arrange 3 of them. So N would be 7 and R would be 3. Okay, so let's think about this without the formula first. Let's just think about if I have these 7 letters and I want to choose 3 of them and put them in a certain order. So for the first letter that I choose, I have 7 options because there's 7 letters. For the next choice, I've already chosen one of the letters, so I only have 6 options left. Then after that, I've already chosen 2, so for the third choice, I only have 5 options left. Now this is similar to the sandwich problem. So I'm picking one thing from 7 things, then I'm picking one thing from 6 things, then I'm picking one thing from 5 things. So we just multiply all those together. 7 times 6 times 5, which equals 210. So the formula does that for us. It calculates this without actually having to think about it. So if we plug those in, again, we said n would be 7. We have 7 things to choose from. R is 3. So we just write the n here, the r here, and then a p in the middle. That's just our notation for permutations. And then we have 7 factorial. Just follow the formula. So n goes here, r goes here. So this would turn into 7 factorial over 4 factorial. So minus 3 is 4. So if we write that out with a multiplication, knowing what we know about factorials, that's going to be 7 times 6 times 5, 4, 3, 2, 1. 4 is going to be 4, whoops, not 5, 3, 2, 1. So if we think about this, all this is being multiplied together. I can cancel out all the numbers that are the same. 4 cancels out, 3, 2, and 1 all cancel out because I'm dividing these numbers when I'm multiplying all of them across. So what I'm left with is the same thing we got up here, 7 times 6 times 5, which is 210. So if you plug it in the formula, it does this whole process for you. So a couple examples on the back. How many ways are there to pick 2 people out of a row of 4? So n would be 4, we're picking 2, so r is 2. If we plug it in the formula, 4p2 would be 4 factorial on top over 4 minus 2 factorial. 4 factorial is 4, 3, 2, 1. Multiply together, 4 minus 2 is 2, so 2 times 1. Cancel those out. 4 times 3, there's 12 ways to pick 2 people out of a row of 4. How many ways to pick 4 people out of a row of 4? So if I have 4 people and I'm picking 4 people, 4 factorial goes on the top, 4 minus 4 on the bottom. 4 minus 4 is 0, so what is 0 factorial? Well, 0 factorial for this reason, since we can't divide by 0, is defined as 1. So 4 factorial would be 4, 3, 2, 1. Multiply those together. 4 times 3 is 12, times 2 is 24. All over 1 is still 24. So if I had to sum this up, if I had a row of 4 people, person 1, 2, 3, 4, and let's say we were picking winners of a contest, how many possible combinations of 2 people could I pick? 12 different people. How many possible ways could I order 4 people? So if you and your 3 friends are deciding how many ways you can sit in order at a movie theater, 1, 2, 3, 4. If you wrote out all the different orders of you and your 3 friends, there would be 24 ways to do that.